for today's session, that is Human and Colorful World. But before we get into the topic, I would like to ask you a few things. The first point I would like to ask you is, what do you remember about refraction? What is refraction? If somebody can tell me just one word for it, then that will be great. Refraction. Come on, people. It's a very simple question. What is refraction? One word for it? Okay, bending of light. Chalo, theek hai. At least one or two students is able to give the answer. Bending of light is basically called as refraction. Bending of light. Now, question is, when the light is traveling from a rarer medium to denser medium, what kind of bending are we able to see? Does it bend towards the normal or away from the normal when the light is traveling from rare to dense? Towards the normal, right? The first is towards the normal. So if your light is traveling from rare to dense, then it is the bending is going to occur towards the normal. Towards normal. And what if the light is traveling from denser medium to rarer medium? Then it is going to be bending away from the normal. Away from normal. Okay, so these are the 2 points. Now with these basic 2 points, we will be learning refraction and prism. But before we get into that, let us try to first understand what is this prism made up of and what kind of shape it has basically. So prism is just a shape, but the kind of device we are looking is glass prism. The device we are seeing is glass prism. Prism is a shape. Glass is the material from which we are making it. So glass prism. And it looks something like this. Like, for example, if you have two triangles as such, and this is the prism we are looking at. Now the prism, it has two triangles. It has two triangles. And the other three surfaces, these are what exactly? These are rectangles. So 3 rectangles and 2 triangles is the basis of what your glass prism is made up of. So I hope you are understanding this, that there are 2 triangles and 3 rectangles. Now question is, suppose let us say these rectangles and these triangles, out of these, which one is the base? Like, are the rectangles the base or the triangles are the base? Triangles are the base. Okay, always remember that triangles are the base, not the rectangles. Rectangles are lateral surfaces. Rectangles are what? These are lateral surfaces. Lateral surfaces means sideways surfaces. So rectangles are lateral surfaces. Triangles are your base. Now, the angle between two lateral surfaces, wherever we are talking about a prism, for example, this is the prism, and there is an angle between two surfaces, two lateral surfaces. This angle is called as angle of prism. It is called as angle of prism. And it is shown by letter A. Let's say there is a specific word we need to use for this. That is the letter. That is A. You cannot use another letter for angle of prism. You always are supposed to use it as A. So A is basically the angle of prism. Angle between two lateral surfaces is going to be called as angle of prism. So these are the two lateral surfaces. These two. This one and this one. So we have A, B, and C. So between AB and AC, you have that angle. That is angle of prism. Now let us talk about what kind of refraction are we going to have. Let us have that first, that diagram, and then we'll be able to learn a lot about this. For example, you have a light ray which is coming incident. Fine. There is an incident ray, this one. And the outside material or the outside medium is air. And the inside material is glass. So the light is currently traveling from air to glass, at least for now. Now, according to our information, air is what? A denser or rarer medium? Air. Denser or rarer? Air is dense or rare. Chalo, everybody has to contribute. If you are just attending the sessions and you are not contributing, you are not never going to understand a single thing. Okay, it's definitely a rare medium. Okay, and what about glass? Glass is a dense material, right? Glass is very much dense. Okay, so the light is traveling from rarer to denser. According to our information, it bends towards the normal or away from the normal then? If it is traveling from rare to dense. We just have seen before some time, if the light is traveling from rare to dense, it is bending towards the normal, correct? Okay, so first we need to draw a normal then. We should have a normal and only then we can talk about this. So this green line is the normal. This green line is the normal. Normal is drawn 90 degree to the surface, so it's a perpendicular line. So this is our normal. Now, according to our information, it is going to bend away from the normal. Okay, so this is the light inside this one. This is our refracted ray. Okay, so this is our refracted ray, that is the inside one. If we give it letters, see, this is suppose D, this is E, and this is F. So technically, this is our line, that is P, Q, E, F is our suppose the incident and the refracted ray. So initial refraction is happening as what? It is traveling from rare to dense, and the light is, let's say, bending away from the normal or towards the normal. Towards the normal. This is towards the normal. Initially, it should have gone towards like this direction, but as there is prism in between, it is bending towards the normal. It is bending towards the normal, and this is the line we have received. Now, in the second case, at this particular point, the refraction, another refraction is happening, but this time the light is traveling from glass to air. So now this time it is traveling from glass to air. According to our information, it should bend towards the normal or away from the normal. See, this should have been the path. This should have been the path if prism was not there. But now it is traveling from glass to air. So it should, let's say, bend away from the normal, correct? Now, if I go, let's say to the top side, it is towards the normal. If I go to the bottom, it will be away from the normal. So the second path should be taken, the bottom part. This one. Okay, so this is exactly the path we have taken. So it's very simple. So let us talk about through a rough diagram. Suppose if we have a prism, this is our incident ray. This is our refracted ray. And the last ray which is coming out, we are going to call it emergent ray. We are going to call it emergent ray. Now question is, we had seen same kind of refraction in glass slab also. This was the glass slab, and suppose let's say there was incident ray, then there was refraction, then there was emergent ray, and we received, let's say, there was lateral displacement between the two rays. That means we received parallel rays at the end. We just want to know why we received parallel rays here, but as you can see, these two rays are definitely not parallel. This one and this one, these are definitely not parallel. So question is, why is this happening? So what is so special about these surfaces? Do you think they are parallel? The one which I have highlighted like pink, are they parallel surfaces? Parallel to each other? Agreed? They are parallel to each other, and that might be the reason why we are getting lateral displacement. Is it okay with you? Are you understanding why in glass slab we are having lateral displacement? The reason being that both the surfaces are parallel to each other. AB and CD. AB is parallel to CD. Okay. Now, are these surfaces parallel? AB and AC. Is AB parallel to AC? By looking at the prism, what do you think? Are they parallel? Come on, people. You are so supple, let's say less interactive. Okay, I really want to know about this. Only one student has given the answer. What is with other students, like the rest of the 21 students or 22 students? So the kind of surfaces what we are getting is AB and AC. These are not parallel to each other. AB and AC, they are not parallel to each other. As you can see, they are completely inclined towards each other. So they are not parallel. So as we do not have parallel surfaces, we are never going to get those kind of lateral displacement. All we are going to get is this kind of diagram: incident ray, refracted ray, and emergent ray. Now, question is, in the exam, what are they going to ask from this? See, the first thing they can ask you from this particular, let's say, topic is what is prism made up of? Matlab, like what kind of surfaces it has, and which are lateral surfaces and which are bases. So that is covered. Another thing they can ask you is the angles which are present between, let's say, for incident ray, refracted ray, and emergent ray. So we'll be studying all those angles. You tell me, suppose there is one incident ray and I have a normal there. The angle between incident ray and the normal, it is called as what? Angle between incident ray and the normal. This one. Angle of incidence. Angle I is basically angle of incidence, and it is present between incident ray and normal. There is another ray that is refracted ray, correct? The angle between refracted ray and the normal, that angle is called as what? Angle between refracted ray and the normal. Angle of refraction. Angle of refraction. And there is third ray, that is emergent ray. Emergent ray. And suppose, let's say, we have a normal there, like this one. The angle between the emergent ray and the normal, it must be called as angle of emergence. So it is represented by angle E, angle of emergence. And angle of emergence is between what? Angle of emergence. It is between emergent ray and normal. So in the exam, they will be asking you for labeling. Most of the time, they will be asking you just for labeling part, or they might just ask you angle of refraction is between whom, or angle of emergence is between whom. The words are very simple. Emergence means emergent ray and normal. Refraction means refracted ray and normal. Incidence means incident ray and normal. So normal is same in all of the cases. As you can see, normal is same for all of the cases. All that is changing is incident, refracted, and emergent. Now there is one more angle which they can ask you, and that is angle of deviation. So let us try to understand what is that, because that is something very new. So what was the original path? If the prism was not available, suppose the prism is not present at that particular position, the original path of the light would have been something like this. If the prism was not there, the light would have traveled like this. But as the prism is present now and the new line is present like this is your new emergent ray, correct? So if we take it backwards, there is one angle between incident ray and emergent ray. This is your what? This is your incident ray. And this is your emergent ray. The angle between these two is called as angle of deviation. That is represented by capital D. So that is angle of deviation. So angle of deviation is something very unique. It is present between incident ray and emergent ray. Very, very unique. So how many angles have we really studied? Can we just count it? Angle of incidence, angle of refraction, angle of emergence, angle of deviation, and are we forgetting one angle? The most important angle related to prism. One angle which we missed. We have seen before some time. If somebody can tell me which angle we have not written here. Angle. Remember the angle A, angle of prism. Most important. Okay, the angle of prism, angle A. So these are 5 angles which are, so let's say, should be remembered by you. You have to, in the exam, either they will ask you for labeling or they might just ask you that angle is present between what. So the most unique one from that was angle of deviation. So angle of deviation tells you about what? By what angle the incident ray has bent. In, let's say, angle of deviation will tell you how much, suppose your emergent rays has bent as compared to your incident ray. So that is what is the idea. So I will just ask you some questions. You just have to give it the answer. And it has to be a quick round. Angle of prism is shown by which letter? Chalo, be fast. Angle of prism. It should be very fast. The answer should be very fast, let's say, coming from your side. Angle of prism. Shown by letter A, correct? Okay, angle of prism. Can you please tell me the angle which is present between emergent ray and normal? The angle present between emergent ray and normal. Even you can give me the letter for the angle, that would still be fine. You don't need to write down the complete angle. Angle between emergent ray and normal. Angle of what? It is called as what? Angle of, if it is E, it must be E, right? That is angle of emergence. All you have to do is use the first letter. It is so simple. The angle between refracted ray and normal. Chalo, be fast. Let me know which angle I am talking about. Angle between refracted ray and the normal. Okay, Sakshi correct, Samruddhi correct, Ritesh correct. Angle of refraction, right? That is angle R. Okay, now you have to tell me what is angle of deviation. This angle is present between what exactly? Which rays? Which two rays? Let's say this angle exists in between which two rays? Incident ray is one, definitely. And yes, Ria correct. One is incident ray and one is emergent ray. Incident ray and the emergent ray, angle D. Correct. Now, okay. What kind of surfaces does glass slab has? Glass slab has what kind of surfaces? Inclined surfaces or parallel surfaces? Glass slab has what kind of surfaces? Parallel or inclined? Parallel. Okay. And what about glass prism? Glass prism. Parallel or inclined? Inclined. Inclined. Okay. Now, let us talk about one of the main points about the glass prisms. In the exam, see, this kind of diagram will be given to you. And they just might ask you the labeling part. So that means they might give you, instead of I, they will just write down here angle 1. Instead of R, they might write down angle 2. Here they are giving angle 3, and they will just ask you what is angle 1, what is angle 2, what is angle 3. So you should know which angles are they talking about. So that will be asked in the exam. Because there is nothing more that can be asked to you from this particular diagram. All they will ask you is labeling part. Now let us talk about white light. So our sun gives us white light. White light is not a single light. It is composed of 7 different colors. So white light is made up of how many colors? 7 different colors. 7 different colors. And which are those colors? We call it Vibgyor. In short, we call it Vibgyor. That is violet, indigo, blue, green, yellow, orange, red. So these are the 7 colors out of which your white light is made up of. Now question is why we don't see those 7 colors in atmosphere, or suppose let's say whenever we go outside, why we don't see these 7 colors. So the reason is because in air, all these colors, they are traveling with the same speed. All these 7 colors, they have the same speed. They have same speed. They have same speed inside the air. So we are not going to see them separately. We just see the white light. We don't see these 7 colors. But if it travels in some kind of medium like glass, suppose if it is traveling through glass, so you are not going to get, let's say the speed is not maintained. All the colors will have different speeds and you'll be able to see those 7 colors. Those 7 colors can be seen. And what is the reason? Because the speed is different. Now question is, how come that speed is different and what is the logic behind it? Like which color has more speed and which has less speed? So first we need to understand what is wavelength. That is the first concept we should understand. Suppose this is a wave, and wavelength is nothing but the distance between two crusts, these two mountain tops. If that is the distance you are taking, that is going to be called as wavelength. Wavelength is generally shown by lambda. So this is the symbol which you generally use for wavelength, that is lambda. So wavelength is the distance between two crest or two troughs. The bottom parts are called as troughs, or you can call them valley. So mountain versus valley, or you can call them crest and trough. So distance between crest or trough is going to be called as wavelength. So that is the distance we are talking about. Now question is, suppose we have two waves, something like this. This is my first wave and this is my second wave. If this is lambda 1 and this is lambda 2, can you, by looking at the figure, can you tell me which one is more, like lambda 1 or lambda 2? It's a distance we are talking about. So what do you think is the larger one, lambda 1 or lambda 2? Lambda 2 looks bigger, right? It looks larger, the distance is more. Okay. So can we say in that particular time, lambda 2 is able to cover more distance? More distance means, can we say it has more speed? It has more speed because it is covering more distance in less time, so definitely it has more speed. So larger the wavelength, larger the speed. Is that the case? That means lambda 2 will be having more speed. The speed of second wave is much larger as compared to the first. No, with that information, I've been giving you two examples. One is red, and another wave which we are going to talk about is violet. Another one is violet, for example. So let me have that. Suppose violet. Wavelength of red is maximum, or you can say the highest one. Highest wavelength. Highest lambda. And the violet light has lowest lambda. Now from this information, can you tell me which will have more speed? Like from our previous discussion, we have seen that more the wavelength, more will be the speed. So if red has highest wavelength, then what will be the speed? Will it be lowest or highest? A red color. A red color will be having higher speed, correct? Red will be having higher speed because it has more wavelength. It can cover more distance, so it has highest wavelength, highest speed, you can say. And what about your violet light? Lowest speed. Lowest speed. Why? Because the wavelength is least. No. Let us talk about a prism now. Let us talk about a prism. Okay, so this is our prism. This is our white light, the incident ray. Now, all the 7 colors are embedded in this white light. Once the refraction happens at this particular point, according to our information, what is happening is the speed is changing. Suppose the speed inside the glass is different for all the colors. So the first wave or first light which is going to come is red. So this will be the one. And the violet light will be looking like this. We just want to know why the red color will be at the top and why the violet color will be at the bottom. So that is the question we need to ask. Now you tell me, red color, what is the speed of the red? Is it high or low? Speed of red, high or low? It's high, right? The speed is very high. Now, if the speed is very high, will it stay in the prism for more time or less time? If the speed of the red is very high, will it stay in the prism for less time or more time? The speed is really fast. So what do you think about the duration it spends in the prism? It will be very less. Okay, less time in prism because the speed is so fast that the red light will, let's say, cover up the ground. It will come out of the prism and it will not stay there for a longer duration. So less time in prism. So can we say if it is staying less time in the prism, it will have less refraction? Can we say like this? That as it is not staying much longer in the prism, it is going to have less refraction. Agreed? Okay with this? Because see, it is not traveling, let's say it is staying there for a very less time. So it must be having very less refraction. Because refraction can happen only if it is staying there. If it is not staying for a longer duration, less refraction. Okay, so less refraction means, can we say less bending? Less refraction means less bending. Agreed? Less refraction means less bending. Okay. Now let us compare the situation with violet. What is happening with violet? Tell me about violet. Is the speed high or low? Violet. Is the speed high or low? Low speed. Correct. In the prism, will it stay for longer duration or less duration? The speed is very slow. So what about the time spent in the prism? Longer duration, right? Okay, longer duration, long stay, long time in prism, long time in prism. But if it is staying longer time, what about the refraction? If it is staying for longer duration inside the prism, what about refraction? More refraction, less refraction? Longer the stay, more will be the refraction, right? Refraction will be more. And what about the bending then? More refraction means what kind of bending are we going to have? Less bending, more bending? More refraction will guarantee what kind of bending? Chalo, answer the question. More bending or less bending? More bending. More bending. Okay. So, is it okay then that the red light was at the top? The red light was at the top. The reason being because its speed was very high. It spent very less time in prism, less refraction, less bending. So that's why it is at the top. But the violet color, it was at the bottom. The reason being because it is having very less speed, more refraction, more bending. So what kind of colors are we going to have? See, we have Vibjor, right? We have Vibjor. No. We are traveling from, suppose, red to violet. Suppose we are traveling from red to violet. Which has maximum wavelength? red, right? And the wavelength of violet is minimum. Okay. So can you please tell me, if red is having the maximum wavelength and violet is having the minimum wavelength, if you are traveling from red to violet, the speed will increase or decrease? The speed will increase or decrease when we are traveling from red to violet? Chalo, come on, answer the question. Your wavelength is decreasing. Okay, so what happens to the speed? Speed will also decrease, right? Speed decreases. If your speed is decreasing, what happens to your wavelength? Sorry, what happens to your refractive index? Your refraction will be more or less if the speed is decreasing. See, speed decrease means it is going to stay for a longer duration inside the prism. So what happens to the refraction? More or less. Your speed decreases means it's going to stay for a longer duration there. So what happens to refraction? More or less. Okay, the refraction will be more. The refraction will definitely be more. Correct. Palak correct. Riya correct. Ritesh correct. The refraction will be more. And then what about the bending part? What about the bending part? Bending will be more or less? Bending more. Okay, ठीक है. So bending is more. Bending more. So question is, who will be at the top? Who will be at the top? Who has less bending, right? The red color I think
Red.
has the least bending. So the most topmost color will be red, then orange, then yellow, then green, then blue, then indigo, and then violet. So let me show you one diagram, and let me ask you if you're comfortable with this. They are saying the topmost part is red and the bottommost part is violet. Are you okay with this? According to their information, it is R first and then the violet. Can you tell me why red is at the top? A question, let's say a scientific reason behind that. Why red is at the top? If somebody is asking you the scientific reason, okay, less refraction. And why it has less refraction? Because why it has less refraction? Either you talk about the speed or you can talk about wavelength. At least one of the points should be clear to you. Okay, because of the high speed. Okay, because of the high speed, this happens. Okay, ठीक है. And vice versa for violet. Okay, ठीक है. In the book, can you see that the topmost color is pink in the book? Like I hope you are able to see in the book that it is pink. They have shown, right? Are you able to see it in your book, textbook, the pink color? Just asking you. Okay, so that's a printing mistake. Fine. That is just, see, these are printed books, the color books, and the kind of quality has not been maintained by NCRT. So you might, let's say, it looks like pink, but it is not pink. The color code should be from red to violet according to Wipchor. But why you are having that pink color is because that's a printing problem. Nothing to do with our actual diagram. So don't ever think that it is pink. It is always Wipchor. Okay with this? I hope that problem is solved. Do not consider that as pink. That is just a printing problem. Okay. Now this is what we have received. 7 colors. These are 7 colors, right? These are 7 different colors. So it's a band. It's a band, and we have a name for this band. We call it spectrum. The band of 7 colors is called as spectrum. The band of 7 colors is called as spectrum. But I just want to ask you a question. Why this splitting happened? Why this splitting happened? Why it didn't initially happen in air, but it happened in glass? We discussed this reason. What was the reason? Why the white light initially was not splitting, but later on in the glass it definitely split? Why? due to different speeds of the colors. Yes, correct. The speed of the colors was same in case of air, but due to refraction, the glass material, the speed changed for every light, and because of that, the splitting happened. And this splitting part is called as the splitting of white light into 7 different colors. It is called as dispersion. The name of the phenomenon is called as dispersion. This has to be memorized, this particular term. So what is refraction? What is refraction? Refraction is bending of light. Refraction is bending of light. And what is dispersion? Dispersion is split into 7 colors. White light splitting into 7 colors. Split into 7 colors. Now, another question for you. Suppose, have you drawn such kind of rainbows in your book? Maybe in your childhood, maybe in the arts class or something like that. Rainbows. And do you remember how you used to draw it? Let's say you used to have lots of different bands, right? And then you used to feel the color inside them. Agreed? Matlab, like you were able to tell like the first band is red, then the second band is suppose let's say yellow and then orange and so on. So such kinds of bands are not possible in case of this kind of spectrum. As you can see, these are continuous. There is no what I can say, there is no background as such, or there is no border as such for the colors. Do you see any kind of border there? Like for every color there is a border. Is it something like that, or they are continuous, like embedded into each other? Look at the diagram and just tell me, are the borders present there, or are they continuous? By looking at the diagram, it should be very easy for you to tell. All you have to do is look at the diagram and you just have to tell whether the borders are present or are they continuous. It is continuous. It doesn't have borders. Like the one you should draw in your childhood, that has nothing to do with our actual colors. So we have continuous colors. We do not have, let's say, borders as such. Now, this experiment of dispersion was done by Newton. This experiment of dispersion was done by Newton. Yes, our gravity scientist. So Newton has done this experiment. So how many prisms are these? How many prism have we taken? Is it 1, 2, 3? How many prisms have we taken for this particular experiment? It's one, right? So this is called as one prism experiment. And from one white light, how many colors you received? From one white light, how many colors have you received? 7? Okay. So, see, when Newton was doing this experiment, he thought that if one light is able to create 7 colors, what if I keep 2 prisms against each other? Like, he thought that maybe if suppose such kind of arrangement, if I do, if I have 2 prisms or maybe something like this, if one prism can create 7 colors, right? One can create 7 colors. So if 2 prisms are used, I might even get 49 colors. Who knows? So 1 has to 7. He thought that maybe I will be getting some more colors as such. But to his, let's say, surprise, or maybe to his knowledge, contrary happened. When he did this experiment, initially he took the white light, he got those 7 colors, but in the in this particular experiment we have just shown 2 colors. One is red, one is violet. But later on they combined with each other. Later on in the second prism they combined with each other, and suppose they again gave us the white light. So by looking at this experiment, can you please tell me how many colors Newton received with 2 prisms? He gave one light. Has he received 7, or he just received 1 again? Again 1, right? Now question is why? Because see, technically he should have received 49 colors, but what is the problem then? I will just draw the diagram and you tell me what might be the problem. These are our 2 prisms. And in the second, suppose let us say diagram, what I'm doing is I'm combining these two prisms. Can you tell me this diagram is looking like what exactly? See, if I combine both of them and I have received this diagram, what it looks like? Do you think these are parallel surfaces? Looks like it, right? Parallel lines. So according to our information, who has parallel lines? Like, have we seen any device which has parallel lines before Prism? Maybe in previous lesson. Glass slab. We had seen such kind of device which has parallel lines, right? And what happens in glass slab? What happens inside the glass slab? Lateral displacement, correct? The light is coming here, then it is refracted, then there is emergent ray, and suppose let's say we are going to have parallel rays as such. Now, why we are going to have parallel rays? Because the refraction which is happening at the one, it is equal and opposite to refraction which is happening at the second point. The refraction is equal and opposite, and that's why that is happening in here also. So if in the exam they're asking you why we are getting again the white light, so the reason is very simple. When you are using two prism, it is creating what surface? Parallel surface. And equal and opposite refraction happens at the first and the second stage. Matlab, like here the refraction and the second refraction, they are equal and opposite, and that's why you are again going to have white light. So let me know if you are able to, let's say, give me the answer for this. Question is, why, if we use two prism, why we are going to get white light again? What kind of reason are you going to tell? A simple scientific reason for this. The two prisms acts as what exactly? The two prisms acts as what exactly? Chalo, be fast. Give me the answer for this, else it would be very hard. Suppose let's say for me to explain it to you. Chalo, be fast. Let me know the answer for this. The two prisms are acting as what exactly? Acting as glass slab. Okay, like parallel surfaces, and because of that, we are going to have this particular white light again. Acha, why not this kind of arrangement? Why not this kind of arrangement? Chalo, we have taken a white light. We have got two colors. Suppose let us say this two colors is one is red and one is violet, for example. Can you tell me if the light is traveling from air to glass, the second case, air to glass, it will bend towards the normal or away from the normal? Come on, people. Chalo, give me the answer fast and let me know what is going to happen. It is going to bend towards the normal, right? So our light will go to the bottom side then? Correct? But then we won't be able to, let's say, study this experiment because this is going inside the surface of our table. We won't be able to study this. So I hope you are understanding why Newton has taken this kind of arrangement, one prism and then another inverted prism, rather than going for two same prisms. Because this will not work, the light will go to the bottom side, surface side, so that is not helpful at all. But with inverted prism, we might be able to do this. So question for you, this two prism experiment, in which of the experiment from the following, one prism experiment and two prism experiment, in which of the two you are going to get seven different colors? One prism experiment, two prism experiment, seven different colors. Dispersion. Chalo, be fast, give me the answer. Dispersion, you are going to get in which prism? One prism, two prism experiment. One prism experiment, right? Dispersion you are going to get definitely in one prism experiment, 7 colors. And what about two prism experiment? You again get white light. You again get white light. Okay. Both of these experiments are conducted by whom? The scientist, the person who has conducted this experiment, one prism and two prism. Both these experiments belong to Newton. Both of these experiments belong to Newton. So in the exam, if they ask you about one prism, you have to give the answer in terms of one prism, and two prism if they're asking, then you have to give me the answer. By the way, in the two prism experiment, uh, are both of the prisms same or one is inverted? Like what kind of arrangement do we have? One is inverted, right? Okay. And why not keep both same? What is the problem? If we keep both of the prisms in the same orientation, what is the issue? The light will go where exactly? Inside the surface, inside the table, which we won't be able to study. Okay, good. So that's the reason. Yes, that. Okay, so you have yes, the light will go inside the surface. Yes, correct. So that is the problem. Now, what we are going to do is we are going to study rainbow, because that is something which, suppose, let's say we can study right now, and that will be easy for us. Now, suppose you tell me A is equal to B, B is equal to C. Could you tell me what is the relation between A and C? Just some mathematical basic point I'm asking. If A is equal to B, B is equal to C, then what is the relation between A and C? Like A is equal to C. Simple logic, right? Okay. Now with the same point, glass prism is equal to rainbow, right? 7 colors you are going to get. And raindrop is equal to rainbow. So can you tell me what is the relation between glass prism and raindrop? If both are giving us rainbow, by using the logic which you used above algebraically, can you tell me the relation between glass prism and raindrop? Just have to apply your IQ basic maturity. Glass prism might be equal to whom? Raindrop. Okay, so the raindrops are acting like glass prism, right? Raindrops are acting like glass prism, and that might be the reason why raindrops are able to create rainbow. So the reason is your raindrops are acting as what? Glass prisms. Okay. So could you tell me then what kind of surface raindrop must be having? Parallel surfaces or inclined surfaces? If raindrops are equal to glass prism, then what about the raindrops? Are they having inclined surface or parallel surface? Your glass prism has inclined surface. What about raindrops? See, if your glass prism has inclined surfaces, if they are equal, then raindrops must be having inclined surfaces, no? If both are equal, then must be glass prism is having inclined surface. Raindrop must be having inclined surfaces. Okay. So we just want to know what happens in that case. See, let us have one circle. See, this is our raindrop, for example. And we are taking one incident ray. So this is our incident ray. Now, it is traveling from air to glass. It is traveling from air to, sorry, not glass, water droplet. Now it is changing the medium. Now what is going to happen? Dispersion is going to happen. 7 colors are going to be created. But what we are going to do is we are just going to show only 2 colors for our understanding. So let us talk about that. One color will be coming from this. That is the red one. Let me extend it backwards. Okay, so this is my red color. Okay. And after the reflection, from that particular point, the red color will be going towards the bottom side here. And here again, the another refraction is happening. This is the one. Now, what about the violet light? The violet light will be coming again in the same fashion. The violet light. Okay, let me extend it. Okay, and the second violet light will be coming from this side. That is the reflection part. And again, the third part here. Okay, so this is what is happening inside the water droplet. We just want to know what is happening at each stage. The first stage, this one. Okay, so at first stage, what is going to happen is your refraction, and the second thing that is happening is dispersion. Agreed with this? Let me know from the figure if you're okay with this, that at the first stage, your refraction is going to happen along with dispersion, because the medium is changing air to water. So refraction, the white light is splitting into 7 different colors. So dispersion also. Both the things are happening at the same time at first point. Now at the second stage, what is happening is reflection. Second stage, what is happening is reflection. Are they going to have refraction here also? Like, is the light going to come out of here also? Yes, that is true. But you have to understand one thing, that we are not concerned about the second component. The white light, this particular red light and violet light, they will be having refraction also. But we are not considered about the second, let's say, the component. We are not worried what is happening after that. So we are concerned only with the reflection part. And the third part, what is happening here? The third one. So the third one, it is going to have refraction again. Again, refraction. Now, question for you. This reflection we are talking about at the second stage, this one, this reflection, is it inside or outside the water droplet? Like, after reflection, the light is inside or outside? What do you think? What is happening there? The light is incident, right? And it is reflected inside or outside? Just by looking at the figure, what do you think? It is reflecting inside or outside? Inside, right? Okay, so we have a word for it. We call it, let's say, internal reflection. We call it internal reflection. We have a word for it. We have a technical term for it. We call it internal reflection. Not just reflection, but internal reflection. And what about the third component? Third component is refraction again. And that's how we are going to get 7 colors. Now, question is, uh, are we going to have refraction here also? Second case. Yes, but we are not concerned about it. Are we going to have reflection at third stage also? Yes, but we are not concerned about it, because we want to have that rainbow. We are not worried about the other phenomena which are happening inside. There are lots of things which are happening inside, but we are concerned only with the reflection part and refraction part and the rainbow which is created. So let us just have a revision. At first stage, what is happening? Chalo, because in the exam, they are just going to ask you what is happening at different stages. Chalo, first stage, what is happening at the first stage? Chalo, be fast and give me the answer. What is happening at the first stage? Okay, refraction and dispersion. That is correct. We are going to have refraction and we are going to have dispersion. Dispersion means 7 colors creation. What about the second stage? What is happening at second stage? The one which we are worried about. Matlab, we are not worried about refraction there. The one thing which we are worried about at second stage, or we are concerned about, reflection. But is it any reflection? No, it is not normal reflection. It is internal reflection. It is internal reflection. And what happens at the third stage? Third stage. Refraction. 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 Okay, so refraction again. So you have understood. So in the exam, what they're going to ask you is, see, the other mechanism they are not going to be interested in. They will just ask you what is happening at each stage, the first stage, second stage, and the third stage. So that is the only part that will be asked to you. Now, a simple question for you: this white light, this white light, this is coming from whom exactly? Who is providing this white light? Any celestial body? Moon, sun? What do you think? Sun? Okay, ठीक है. So sun is providing, right? Okay. So question is, there are two positions. Suppose this is your sun and this is your water droplet, right? And you are standing here. And the second case is, the sun is here, you are standing here, and the water droplet is in front. Can you tell me in which of the cases the rainbow will be visible? The first case or second case? Okay. Just watch the diagram and you'll be able to give me the answer for this. In the second case, right? So that means in the first case it's not possible, the rays are going to other side, but in this case the rays are definitely entering in your eyes. You'll be able to see that rainbow. So what is the condition? The sun should be behind you. Is it the case? The condition required for rainbow is that the sun should be behind you. Would you be able to remember this, that the sun needs to be behind you to see that rainbow? Otherwise it is not possible. Okay. In your textbook, before 11.5, there is one concept called as 11.5 in your book, atmospheric refraction. There is one paragraph just before that, the end paragraph. Could you see that? Before atmospheric refraction, there is a paragraph. You can see a rainbow on a sunny day when you look at the sky through a waterfall or through a fountain with the sun behind you. Could you please underline that in your textbook? In your textbook, you just have to underline that statement because it is missed many a times because it is at the end of the paragraphs. So you might not notice it, but question can be asked on that. Have you done that? Have you underlined that particular word? Let me know if you have underlined that particular thing. Sun behind you. Have you underlined that? How many times I have to ask you just a simple question? Okay, good, good. So what we are going to have is, in the upcoming week, we might be having some, suppose extra period somewhere. So I will let you know where we are going to put it. And we'll be studying the next of the points, let's say in the upcoming session. That is about atmospheric refraction, twinkling of the stars, then sunrise advance, sunrise sunset, and the scattering effect. But what I want you to do is you take out some time today and you read this topic so that if you have any doubts regarding this, you can ask it in the next class. So if there is any doubt, you can ask right now. If you do not have, then you can read the topic and you can ask it in the next class.